in this video, we're going to be talking about the probability of simple events. All right, so in an earlier video, we talked about sample space. So you may remember the problem. Belinda went shopping for a new shirt. She could choose between 3 colors, red, blue, and white, and 3 styles, long sleeve, short sleeved, and tank top. All right, so how many possible outcomes were there? All right, so then we also, in that last earlier video, we talked about the counting principle, which says if you just want to know how many outcomes there are, you multiply the number of events for each part times each other to get the total possible outcomes. So there were 3 colors, and there were 3 styles, right? 3 colors, 3 styles. And so if we multiply those 2 together, then we know that there are 9 outcomes. All right, so there are 9 possible outcomes. Now, suppose Belinda closes her eyes and picks a shirt. Okay, what's the probability that she's going to pick a red tank top? All right, so if there are 9 different outcomes, then how likely is she to come up with the red tank top? Well, the red tank top is just one of the 9 outcomes. So we would say her probability, if we looked at it, we go back and look at all the possibilities before, we know that out of red, she could pick long sleeve, short sleeve, or a tank top. That out of blue, she could do the same thing, long sleeve, short sleeve, or tank top. Or if she chose white, long sleeve, short sleeve, or tank top. Okay, so these were our 9 outcomes, right? We want to know what's the probability that she chooses the red tank top, that she chooses this one. All right, well, it would be 1 out of the total, 1 out of 9. The probability is 1/9. Right? If Belinda opens her eyes, then what's the probability of her picking the red tank top? Okay, well, if you can see, how likely are you to get the red tank top if that's what you're looking for? We would say that the probability in that case is 100% because she just has to look. When she closes her eyes, she might choose any of them. All right, so if we go back now and we say, well, what if her eyes are closed? Is it less likely or more likely to pick a red shirt than a blue shirt? So think about that. If her eyes are closed, okay, is she more likely to pick red than blue, or is she less likely to pick red than blue? Well, if your eyes are shut, you can't see. So and since there's the same number of red and the same number of blue, she's just as likely to pick red or blue. So we would say neither. They're equally likely. Okay, what's the probability that she'll pick a white shirt? Okay, well, white, just white, not white tank top. Okay, so that's a little different. So if we go back and we look at our outcomes, out of 9 different choices, how many of them are just white, or a white shirt? Well, actually, these 3 down here, right? 1, 2, 3. So we would say 3 out of all of them, all right, is her probability. 3 out of 9 would be the probability of getting a white shirt. Okay, and if we write this as a fraction, then we can also simplify it, right? These are both divisible by 3. So her probability of getting a white shirt is actually 1 out of 3, 1/3, right? For every 1 shirt, or for every 3 shirts, right, 1 of them's white. Does that guarantee she's going to get a white shirt? No, we're just talking about probability, how likely it is. All right, so then what is the probability that she would choose either a red or white shirt? Okay, so now we have 2 different colors, right? What's the probability that she would get one of those? All right, so then if we look at red, how many are red? 1, 2, 3. How many are white? 4, 5, 6. So this time we have 6 possibilities, okay, out of how many? 9. All right, so the probability of red or white is better, right? Because I have more outcomes that would fit this, red or white. And again, this can be simplified. This is divisible by 3. So this is 2 out of 3. For every 3 shirts, 2 of them are either red or white. Okay, so did the probability get better for red or white? Yes, because there were more true, okay, more possibilities that would make this true. All right, so what's the probability that she would pick a green shirt? So if we go back and we look at our sample space, how many of these are green? Well, none of them. So is she likely to pick a green shirt? No, we would say her probability of a green shirt is 0, or we're going to see that probability can be written not just as fractions, but as percents. 0%. She's not going to pick a green shirt. All right, so note at the ones we looked at, the closer the probability got to 1, right? The closer it got to 1. So we started with, we had a a 1/3 and we had a 2/3. Okay, the closer it got to 1, which of these was more likely to happen? All right, was it 1 out of 3? Was she more likely to get the white shirt, or was she more likely to get the red or white shirt? 2 out of 3. Okay, the closer it got to 1, so the 2/3, the more likely the event was to happen. Oops, sorry, right? Because you had more different outcomes that would make it true, right? So the closer this got, because 3/3 would be 1 whole, right? So 2/3 is going to be closer than 1/3. So the closer this was to 1, the more likely it is to happen. All right, so just kind of keep that in mind as we continue to talk about probability today. All right, so we haven't really defined what probability is. We've just kind of been using it. And hopefully you sort of understood what I was talking about, but really probability is just the chance that some event will happen. Okay, it's not a guarantee, it's just how likely it is to happen. What's the chance that it's going to rain outside? Okay, that's a probability. It doesn't guarantee that it's going to rain outside, it's just a chance. All right, probability is found using a ratio. Okay, remember ratios can be used. Can be written as fractions, so that's why we were writing it like 1/3. We were writing it as a ratio or writing it as a fraction. You're going to see this P next to some parentheses. This is the way to say that you're finding probability. The P stands for probability. The event is what you're finding the probability of. I'll show you more about this. But the ratio you're going to write is the number of favorable outcomes. So what you want to happen, like picking a white shirt, how many times can you pick a white shirt? Over the number of possible outcomes. How many shirts are there? Okay, so when we found that there were 3 white shirts and 9 possible shirts, right, we wrote it as 3/9, and then we simplified it. All right, it can be expressed, probability can be expressed as a fraction, decimal, or percent. Okay, most likely you're going to start with a fraction, but you might change it to a percent. And then in this video, we are talking about simple events. So what's a simple event? A simple event is a single, okay, single meaning one event with only one outcome, such as tossing a coin once. If you toss a coin, there's only one thing that's going to happen, heads or tails. If you roll a dice, only one thing's going to happen. You're going to get 1, 2, 3, 4, 5, or 6. All right. So let's look at some examples of this. A bag contains letter tiles, R, M, S, A, and B. All right, so think about those little Scrabble letters. It's inside a bag. A letter tile is chosen at random. What is the probability of choosing the R? All right, well, if this is all that's in the bag, and we're going to assume that it is, then how many R's are there? 1. Okay, so there's 1 R. We want to find the probability of getting the R, of choosing the R. So we're going to write this as a capital P, and then in parentheses, we're going to put R, and we would read this, the probability of R, or the probability of choosing R, would be what? 1 R, that's the number of favorable outcomes up here, right? Number of favorable, over the total possible. So how many letters are in the bag? 1, 2, 3, 4, 5 out of 5. 1 out of 5. Okay, that's the probability. If we want to change this to a decimal or percent, we're just going to use the same rules we used before. So if I'm going to change this to a percent, first I have to change it to a decimal, right? So top in, bottom out. Top in, bottom out. Add my decimal and my 0. 5 will go into 10 2 times. So this can also be written as 0.2. Now we don't normally write probability as just a decimal. Sometimes we'll start it as a decimal, but we we'll always use it as a fraction or a percent. So if we go ahead now and change our decimal to a percent, FDP, right, move it 2 places to the right, where it means we're going to add a 0, so this becomes 20%. All right, so the probability of choosing R is 1 out of 5, or 20%. Okay, what's the probability of a 4-colored spinner, red, blue, green, and yellow, landing on green? Right, so I have a picture of a spinner here. If I spin it, what's the probability that it's going to land on green? All right, to write probability, write it as a ratio of of what you want to happen. Okay, we want it to land on green. So there's 1 green out of how many possible? 1, 2, 3, 4. Okay, did I count the green? Yes, because it's 1 of the 4 possibilities. So I want it to land on green, but I have to count how many there are total. Right? So the way I would write this is the probability P next to green in the parentheses Okay, probability of choosing green would be 1 out of 4. All right, so let's think about this. What's the probability of not landing on green? Okay, what's the probability of not landing on green? Well, if I look at my spinner, how many of these are not green? 1, 2, 3. 3 out of how many? 1, 2, 3, 4. So I could say the probability of not landing on green, so the probability of not green would be 3 out of 4. Okay, and again, these you can go back and change these 2% into decimals. So if I went ahead and did that, if I went back and looked at these and said top in, bottom out, 4 going to 1, it won't. Add a decimal, add a 0. 4 going to 10, 2 times. Subtract and get 2, bring down another 0. 4 going to 20, 0.25. And if I change it to a percent, that would be 25%. Okay, if I do the same thing with 3 out of 4, if I change that to a decimal. Okay, 4 won't go to 3, add your decimal, add your 0. 4 going to 30, 7 times. You subtract, you get 2, bring down a 0, 4 going to 25 times. All right, so 0.3 or 3 out of 4 is 0.75, or if I move it 2 places, 75%. All right, so the probability of landing on green is 25%. The probability of not landing on green is 75%. All right, when you find the probability of what will not happen, what doesn't happen, it's called the complement. So it's not the same complement as telling someone they look nice today or you like their shirt. Okay, this is different. This is probability and complements. So in probability, complements is what's not going to happen. What's the likelihood that it won't happen? Notice when we have the probability of an event and its complement, they're always going to add up to what? We'll look at what we had here. The probability of it landing on green was 25%. The probability of it not landing on green was 75%. If I add those up, it was 25 plus 75, 100%. All right, so they should always add up to 100%. Or if I look at the fractions, 1/4, 1 out of 4, plus 3 out of 4. What's the total there? 1/4 plus 3/4, 4/4, or 1 whole. So when you find the probability and its complement, it should add up to 1 or 100%. Or 1.0 if you're using a decimal. But typically in probability, you're either going to see it as a fraction or a percent. All right, so let's look at another example. It says John rolls a number cube 1 time. Find the following. So this is a number cube. This is what they're talking about. The probability of finding 4. Well, first we need to know what's on a number cube. Okay, so what's my sample space? What are the outcomes of rolling a number cube? You could get a 1, 2, 3, 4, 5, or 6. All right. The probability, remember, they're asking for probability, that's what the P stands, of what's in the parentheses of a 4. So the probability of a 4 would be how many 4s are there? There's 1 out of how many total? 1, 2, 3, 4, 5, 6. 6. Okay, 1 out of 6. And then if it doesn't simplify, we're going to leave it. If it doesn't tell me to find the percent, then I can leave it as a fraction. If you want to find a percent, you just divide it and find the percent that way. Okay, and let's look at this next one. So the P stands for probability. What's the probability of what's inside the parentheses? The probability of a 1 or a 3. All right, so the top of my ratio is what I want to happen. So 1 and 3, how many are there? 1 and 2. So there's 2 things that would make it right. Out of how many total? 1, 2, 3, 4, 5, 6. So the bottom part doesn't change, 2 out of 6. Can this be simplified? Yes, these are both divisible by 2, so when you can, you simplify to 1/3. Okay, this next one is the probability, and then what's that symbol there? Greater than 2. All right, so what is the likelihood of rolling a number that is greater than 2? Well, first we have to figure out how many of these numbers in our sample space are greater than 2. 1, 2, 3, 4. The 3, the 4, the 5, and the 6. So that's 4 that are greater than 2 out of how many total? 6. 4, 6. Can you simplify it? Yes. Then you have to. By 2. Divide by 2. So this becomes 2 out of 3. 2/3. All right. Next one, the way you read this, the P stands for probability of what's inside. The probability of a multiple of 3. Multiple of 3, what does that mean? Multiples of 3 are 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. Okay, well on a dice, all right, how many multiples of 3 are there? Well, I have the 3 and I have the 6, all right? So those are the 2 multiples of 3, all right? So there are 2 of them out of how many total? 1, 2, 3, 4, 5, 6, 6. Can you simplify it? Yes. All right, then you divide it by 2. And you get 1 out of 3. All right, over here, the P is probability of not 3. So what's the probability of not getting 3? All right, so you go back and you look at how many of these are not 3. 1 and 2, can't count that one. 3, 4, 5. 5 of them are not 3 out of how many total? 6. Does that one simplify? Nope, then that's your answer, 5, 6. Okay, this is the probability of an even number. All right, so look at your sample space. How many of them are even? The 2, the 4, and the 6, right? Even is 2, 4, 6. All right, so that's 3 out of all of them. All of them would be 6 outcomes. Does it simplify? Yes, it does. Okay. Oh, not by 2 though, by 3. All right, so this simplifies to 1 out of 2, 1/2. All right, and then the last one is the probability of 7. So we go and we look at our outcomes, right? How many 7s are there? 0. Out of how many? 6. All right, so then the probability of 0 out of 6. Okay, can this be simplified? Well, 0 over 6, remember this is another way to write divide. So 0 divided by 6 is what? Well, it's over the line, right? So this is just equal to 0. 6 times 0 is 0. So the probability of getting a 7, 0%. All right, and the last one, it says a bag contains 5 blue, 8 red, and 7 green marbles. A marble is selected at random. Determine the probability the marble is red, right? We could write this with a P, the probability of red in parentheses. Okay, there are how many red ones? There's 8 red, okay? Out of how many? Okay, so remember this number on bottom is the total, not without the red, but including the red. So I have to add the 5, the 8, and the 7. Okay, so 8 plus 7, 15, plus 5 is 20. So this would be 8 out of 20. Does it simplify? Yes, they're both divisible by 4. So this becomes 2 out of 5, 2/5. Right? The last question is, what is the complement of the event? Remember, complement is what is not going to happen. So the complement of red, right, would be not red. The probability of not red is the complement. Okay, and how do you find that? Well, how many of these are not red? The blue and the green are not red. So how many is that? 5 plus 7 is, what's 5 plus 7? 12, okay? So 12 are not red out of the total, all right? So I'm gonna go back. The total again was 20 out of 20. Does that simplify? Yes, by what? By 4. This becomes 3 out of 5. All right, notice we said this before. The probability and its complement, the probability of red and not red, should always add up to what? Either 100%, right here, 100%, or 1. So do 2/5 plus 3/5, is that gonna add up to 1? Yeah, 2/5 plus 3/5 is 5/5, which is 1 whole, okay? All right, you have the probability of the simple event. Simple event is just one thing happening. You're rolling the dice one time. You're flipping the coin one time. You're spinning a spinner one time. What's the probability that that's going to happen? The way you do that is to write the ratio. What you want to happen, your favorable outcomes, over how many total. Remember, it's all the possibilities, right? You can change it to a fraction, or simplified fraction, decimal, or percent. Just use FDP for that. And then remember, the complement is what's not going to happen. All right, together the probability and its complement is 1 or 100%. All right, see you soon.